Yeah. So good morning, everyone. As I mentioned in the last session, there will be two assignments in this course. One prior to the mid semester, one after the mid semester. In the handout that was originally uploaded in the eLearn portal, uh, only one assignment was mentioned. So I have corrected that, and the the two assignments have now been included, and weightages are 5% for the first assignment and the 10% for the second assignment. Accordingly, the weightage for the comprehensive examination, the open book examination at the end, has been reduced from 50% to 45%. So kindly download the revised handout as well as, and it also contains the dates for various evaluation components. Yeah. Okay. So let's get started for today's session. In the last session, we had a brief introduction about software architecture. Now, today we are going to look at some of the key inputs that influence the software architecture of a system that we are trying to design. Okay, so those key aspects or key characteristics of the system are also called quality attributes of the system. So today we look at this quality attributes. So what are those requirements, and what are the commonly used tactics or mechanisms that are used to achieve or achieve the quality attributes. And sometimes when we try to achieve one quality attribute, like say performance, it may impact the overall maintainability of the software, or the security of the software, or vice versa. So we need to look at which is more critical and have some kind of a compromise to achieve the quality attribute that is most critical. So that is called design trade-off. So we'll look at some examples of that as well. So the input to the architecture, if you see, the input for architecture are the business goals. As I said in the last session also, it's very critical to understand why the company or the organization wants to go for a system. So it could be, for example, to improve the customer service. So ultimately, whatever we do, whatever architecture we do, is to ensure that the customer service is improved, and we need to understand what are the impediments right now. It may even require a complete redesign of the customer service process to actually meet that goal. So it is not that we have to fit in the existing process as such. So we need to use our we have to wear our thinking hats and see how the business goals are really met. So ultimately, if the architecture is excellent but it doesn't meet the business goals, it doesn't make much sense. So some element of I'm sure most of you might have heard about design thinking, right? So design thinking is something that really looks at it from the client perspective to solve a problem. So that element has to be a little bit kept in mind here. So business goals are extremely important. Then comes the detailed requirements, the functional requirements. What are the functions that are expected to be performed by the system, the software, and also the non-functional requirements, what we call as quality attributes here, such as performance, what's the response time, what should be the uptime, because certain systems have to be up 24/7, and the failure should be very, very small, and so on. So these kind of requirements have to be understood. And sometimes we also have to fit in the new system that we are trying to design in an existing environment. So it's not that always that we can do whatever we want, we can employ the best and the greatest technology. We are sometimes constrained by some existing systems. For example, there could be a mainframe already in place with which we may have to interface. So that is not under our control. Similarly, the availability of staff, certain existing technology choices that the company has already made. Let's say the company has decided that they will use .NET technology. So you cannot go for something else which is outside of .NET, which is not sort of compatible with .NET. So these are some of the constraints that may come into play when you are trying to do the architecture, right? So we are going to look at some of these in more detail. So hopefully, Kunal, your questions may get answered as we go along. So just hold on. And the functional requirements help us to understand the various modules, and the quality attributes help us to understand to structure these modules, how they're interconnected, and so on. So the importance of why we need to understand the quality attributes. So if you take an analogy of building a house, so you may say that functionally we need 2 bedrooms and a hall and a dining and a kitchen. So we can design in several ways, but there could be some certain quality attributes like we should have excellent sunlight, and there should be very good ventilation and so on. So these kind of requirements are non-functional requirements, but they help us to design the architecture in the correct way. So similarly in our software design as well, the functional and the non-functional requirements play an important role. So for example, in a software scenario, in an ERP system, we may have different functional requirements like the order module, the manufacturing module, the marketing module, and so on, and detailed requirements pertaining to each one of those. But when we talk about the non-functional requirements, the requirement could be that we need to design a system which is portable. That is, once you design a system in, say, Unix platform, the customer or the management may say that we should develop in such a way that tomorrow when we move to Windows or some other operating system, it should be easily portable. So in that case, we need to ensure that there is a layer which sort of shields all the business components, the application that we design from the operating system accesses. So that when we change to a different operating system, that the layer that shields has to be replaced, but not the entire software. So such things help us. Such requirements like portability of software, if that is a requirement, that's your quality attribute, and it helps us to design the system in the correct way. So here are some examples of various quality attributes, and there are many more. So for the first one here given here is availability. That is how much downtime can we afford for the system. So some systems they want to be up and running 99% of the time. So its availability is 99%, or some systems have to be even more available, 99.99, or even several decimal points after 99. So it depends on the criticality of the system. For example, if you are talking about a nuclear power plant or a space shuttle or a medical device, these kind of things are so critical that we cannot afford them to fail at any given time. So there has to be, the design has to take care of all eventualities. Whatever can go wrong, can fail. We need to ensure that even if it fails, it keeps working through the design, through proper design. Similarly, we talk about performance. We'll talk about some examples of high performance. Modifiability. This is, I think, a given in any software these days. One cannot think of designing a software which is hard to maintain, because the life of software once it's developed runs for many years, 10 years, 20 years, or even more. So during that time, whatever business rules and business requirements as they change, we need to modify it, modify the software. So it has to, the design of software should be such that it's very easy to modify. Testability, as you know, if every time we go for a new release, we need to ensure that it is well tested, it doesn't break what is already working. So the amount of effort we put in testing the system should be minimal, as less as possible. Usability, so this is how easy it is for the end users to use the system, both for the end users as well as people who are sort of operating the system from the operational standpoint. Interoperability, I think this is becoming more and more critical these days. no system or very few, there are very few systems who do not interact with the external system or external world. So how easy is our system for other systems to interact with, right? So giving the proper application programming interfaces, APIs, so that the external systems can easily talk to us. So that is something they need to look at. And the security. So obviously with more and more hacking and malicious users trying to crack the system, one has to make sure that the security is sufficiently taken care of. So these are some of the quality attributes, and in today's session we are going to look at what are some of the issues that come into play to satisfy these requirements, and what are some of the solutions that we can put in place to address it, right? So one of the questions is NFRs, non-functional requirements. Venkat is asking, are they same as quality attributes? Yes. So these are some of the non-functional requirements, and they're also the quality attributes of the system, right? So so how do we achieve these quality attributes? Partly we have to achieve this through our coding. For example, if you're talking about performance, an efficient code will help in performance, but that alone may not be sufficient. So we may have to have other mechanisms to improve the performance when there are too many requests coming at the same time, right? So partly through coding and partly through architecture. So this is what I was telling you, that suppose you want to have good response, an algorithm can be improved to have a good response. But at the same time, if we distribute the software on multiple servers and the more requests are coming, then the requests can be directed to different servers, so that there is a load balancing, and the requests need not have to wait for a very long time if the queue is long, right? So these are other mechanisms other than coding which will help through an architectural way a better performance. Similarly, if you want to develop a software that is easy to modify, the architectural approach would be to have a modular approach, different functional modules. At the same time, the coding has to follow certain discipline. We have various conventions, variable naming conventions and code writing conventions, which will also help in easy maintainability. So now let's look at the quality attributes one by one. So availability is the ability of system to minimize system outages, and we have measured generally by the percentage of uptime. So for example, the system fails say once in 100 days, and the time it takes to recover is 1 day. So it takes 24 hours to recover. So out of 100 days, it is down for 1 day. So in this case, the availability is 99%. If it is down for 2 days in 100 days, then availability is 98%. If it is average downtime is 0.5 days in 100 days, then the availability is 99.5. So this is how you express the availability of system, right? So the way to calculate the availability is you have to measure how long system runs without failing. That is called time between failures, and we need to take an average. So let's say there are different incidents of system going down. For each time before it went down, how long it was running. So that is the average time between failures. And on an average, how long does it take for bringing the system back to regular operation? So that is called time to repair. So that if the total time is the average time it runs without failing and average time it takes to repair. So this is the total time. And the availability is the mean time between failures divided by the total time. So this time divided by the total time. That is the availability of the system. Right. So that is called the availability. So there's a question I just noticed that if from Khushbu, if we are designing a retail industry globally, does architecture include physical data centers at different global locations. Yes, definitely that if we want to have good performance, if you know, we will talk about certain companies which do that. So they have multiple data centers in different geographical locations in different countries to improve the performance as well as the reliability. So yes, that is also part of the design. So coming back to availability, so this is how we calculate the availability of a given system. So Dimit Chadda is asking availability should be 5 nines. Sorry, I didn't understand the question. So how do we ensure the continuity of processing in the event of server failure? So if there is just let's say this is your program on the client side and the database server on the server side connect database. Any failure of any of the components will bring the system down, right? But if you have a primary server and a backup server, then if the primary fails, we can run this program on a backup server, bringing it up, right? So that way your continuity is there. But how do you ensure that the backup server knows that the primary server has failed? Is by having a this is how the backup program knows the current status of the primary server. So as the primary server is doing the salary calculation of a large number of employees, it keeps sending a message to the backup server as and when it finishes the processing of a particular employee. So the backup server knows what is the last employee for which the salary has been processed, right? And the way for the backup server to know that the primary server is failed is that at regular intervals, the primary server keeps sending a message called "I am alive." It's called the heartbeat message. So the backup server knows that the primary server is working properly. The moment it does not receive the heartbeat message, it knows that something is wrong with the primary server, and it starts processing the salary from the next employee that needs to be processed. So that way you are ensuring continuity of the processing, and the overall system availability is improved. So it doesn't have to wait for the server to come up, right? Similarly, if the primary now the question is, if we said that if the primary server fails, the backup server can detect and it can start. But what if the backup server fails? If the backup server fails, then there will not be any backup. So in that case, the primary server will have to start one more backup and keep the backup program, the new backup program, informed about the current state where it is, so that if the primary server then fails, the backup server can come on. Similarly, if the primary server fails, the backup will start, and the backup now becomes a new primary, and it will also start a new backup, so that at any given time there are two machines that are constantly available for doing the processing, right? So therefore, the two-way heartbeat message is required, so that the primary also knows the health of the backup, and the backup also knows the health of the primary. And if any one of them fails, they can take appropriate action to bring up one more server. Okay. So now coming to some questions. This example for availability is more so multi-system architecture. How it relates to single embedded system with multi-object classes and threads. So I'm not very sure if I understand the question correctly. So this is just an example of how in a given situation one can improve the availability by having a backup, either a server or a program, whatever you may call it, a backup component which can take over from the primary. So in different situations, one has to employ different techniques. For example, in case of database, if the primary database fails, we can have a secondary database or a backup database which is also constantly updated on whatever is happening in the primary. So depending on whatever system you are designing, this principle can be used. Okay. Is it the same as the application of data? Yes, that's another thing that we can use for data for ensuring availability of the database. Does it cause overload on infrastructure? It does put some load. It does increase the processing. Therefore, yes, it does put some amount of extra load. So that's where we need to weigh the pros and cons. While it improves the availability, it may decrease the performance slightly. So one has to see whether it is acceptable or not, and which is more critical or which is more important. Can there be multiple backup servers? The question asked by Sanjana. Yes, of course. So as I said, if one server fails, we are going to the other server. What if that server also fails before it can bring up the another server? So there can be multiple levels of redundancy. The more servers you have, you can say that our availability is very, very high. So in spite of 2 servers going down, you can have a third server which will act as a further backup, so that can run. In spite of 3 servers going down, we have 4 servers, then availability is even more. So we'll see how we can calculate the availability based on the number of servers we have. So I want to share the availability is measured in 5 nines, meaning downtime is less than. Okay, so we'll talk about this, Dimit Chadda. We'll talk about how to calculate the availability, whether it is 99%, whether it is 99.9%, etc. How do we calculate that? We'll come to that shortly. What's the difference between server and DBMS? So server is a machine on which this DBMS is running in this particular diagram. Is it necessary to keep the backup and primary server in sync? Absolutely. That is why we saw in one of the diagrams here. In this diagram, we are seeing that the 2 servers, 2 programs are in sync by the primary program sending a message to the backup program, telling the backup program up to which employee the salary has been processed. So that is how it is keeping the two programs in sync. How to switch back on primary again? So basically, when the primary fails, the backup takes over, and it creates one more backup. So when it takes over, it becomes a new primary, and then it starts another backup. Can a system be 100% available for real-time scenario? So 100% is always a myth. You can reach very, very high level of availability, 99.99999, etc. But you never know. If there's a catastrophe, everything can go down. So yes, the probability is very small of everything going down. But yeah, 100% is only possible theoretically. Practically, it will not be 100%. In a multi-tenant system, the load balancer generally takes care of job looking at heartbeats. So yeah, possible. But essentially, the load balancer's job is to balance the load, and yeah, maybe it has an extra responsibility to monitor the health and bring up additional servers. So this is how to come to know about server failure. Is this something programmer has to write logs? So the fundamental approach to identifying whether server has failed or not is the approach that we just described. Now there can be several tools and products already available in the market which we can use, like one of the persons here said that the load balancer can do the same job. So one need not always write the code for it. For availability testing done as part of business continuity planning test, what parameters should be considered and what checks should be carried out? The business has to tell us what kind of things should be continuously running and for which they require high level of availability. So based on that, we have to design the test plan and carry out the test. So there is no hard and fast rule. You are right that if the business continuity planning is there, then the business will tell what sort of continuity they require. Some systems may there are different applications in the enterprise. Some of them need to be highly available, some need not be. So it depends on what the enterprise wants. Okay, fine. So let's go ahead with this session on other things. So I was telling you, how do you calculate the availability of a system? So if there is only one server, the probability its availability is nothing but the probability of system being up. That is 1 minus probability of failure. So let the probability of server going down is 1%. It is 1 day out of 100 days it is down. Then the probability of server going down is 1%. That is 0.01. So availability is 1 minus the probability of system failure, which is 1%. So 1 minus 0.01 is 0.99, which is 19%. So this is how we calculate for the one server. Now let us see what happens when we have two servers. So when we have two servers, we have one server backup, the availability increases. Okay. So probability of one, let's say the probability of one server going down is 0.1%, 0.01. So the probability of both servers going down, that is when it becomes completely unavailable. The entire system becomes unavailable. So that is the probability of one server going down multiplied by probability of the next server also going down. So 0.01 into 0.01, which is 0.0001, which is nothing but 0.01%. That is 0.01 day in 100 days, which is nothing but 0.01 into 24 hours in a day. So that is 2.4 hours in 100 days. Okay. So your this is your probability of server going down. Now the system availability is 1 minus the probability of the entire system going down, which is 1 minus this probability. So that becomes 0.999949, which is 99.99%. So this is with an assumption that the probability of one server going down is 0.1. But this assumption may may not be true for all servers. So if the server availability is 2 days, if the downtime is 2 days for within 100 days, then it will be 0.02. So entire calculation will have to change if the probability of server going down is 2%, right? So and this is just an example as to how you can calculate the availability of our entire system depending on the number of servers you have. So here we assume two servers. So the probability of one server going down multiplied by the second server going down. If you have three servers, it will be 0.01 into 0.01 into 0.01. Then you have to apply the same formula and calculate the availability. So basically, the more the number of servers, the more the availability of the system, and this 99.99 will become even higher, 0.999999, etc., which may be required in certain critical systems. Okay. So now let's discuss what are the reasons or what are the issues that can happen that cause the system to go down. So one simple issue we saw with the server going down. Can you quickly type in the chat what are the possible other reasons that can bring down the system? Why a system may fail? So network issue is one, hacking, natural calamity, power interruptions, memory is full, DDoS, denial of service attack, data load, hardware, system environment. Okay, good. So I think you captured all the code fault. Very good. Error in code, application issue with new deployed code changes, firewall issues, poor algorithm, yes, human error is exception. Excellent. So these are all very good reasons. So let's look at some of the things that we can do. I've taken only few of them here right now. Let's see what solutions can be there. So for disk failure, I'm sure by now we have discussed this already. You can have multiple disks. For server failure, again we can have multiple servers. For link failure, we can have multiple redundant paths to reach the different servers that we have. So that is one. Malicious user floods the system with fictitious login. So this is your DDoS, denial of service. So what can we do for this? Any thoughts? If we have a malicious user who floods the system with fictitious login, so you can have a CAPTCHA, okay, firewall implementation, block the IP, strong authentication, increase IPs, okay, yeah. So both prevention and even if it happens, taking care of it. Whitelisting, do continuous monitoring, very good. All right, so that is good answers. Unable to reach a remote application or service. What about this? Suppose we are trying to connect to a service and the service is not reachable for some reason. What can we do for it in a distributed system? Restart the service, check out application timeouts, fault tolerance, flip to backup service. Okay, good. Auto heal, cache, health checkup, lesser connection timeout, check the logs, firewall check, firewall checks. Okay, all right. Flip to say, okay, good. So as we see, there are multiple solutions that we can have depending on the possible reasons. So here are some possible solutions. Kindly have a look. Okay, so now I'm going to give you some examples of reliability, very high reliability. So in a space shuttle program, where you want the availability and reliability, more important, reliability has to be very, very high. They actually run multiple copies of the same program written in different ways. So it is not that the same program is running on multiple servers, but a completely new way of calculating a result. A new algorithm is used, and the result of these algorithms are checked to see whether the result is matching or not, and then only a decision is taken. Similarly, in the Boeing 777, they use the technique called triple modular redundancy. So there are 3 different modules which calculate the result using 3 different algorithms or 3 different ways, and if the results differ, they take that result which is given by at least 2 computers or 2 processes. So this is called triple modular redundancy, right? Now coming to the performance. Performance has got different ways of measuring performance. It's not just the response time that we're talking about. So that is the basic measure of response time is called latency. So we say that time to respond is 3 seconds, but there are also other measures like the throughput. the number of requests handled per second is, let's say, 3,000 transactions per second. So this is how we measure the performance or the throughput of a database. Similarly, the jitter of response. Jitter of response is nothing but the variation in the response time. So sometimes the response is 3 seconds, sometimes the response is 5 seconds, and this variation may happen because of various reasons. For example, if the number of users is very large, then the response times may vary. So this kind of variation is called the jitter, and the deadline is what the maximum time within which the response should occur. So these are some of the terminologies and measurements in the domain of performance. So latency is nothing but the time between the request and response time. The throughput, suppose this is 1 second, so different requests are coming at different points in time within this 1 second, and the responses are also there coming. So we have to see how many transactions or how many requests were processed in 1 second. That is called the throughput. And the variation. So this is your each request is on the x-axis, and the time it takes to respond, the latency is the y-axis. So sometimes the response is taking more time. Here it is taking a little less time, so etc. So the difference between the upper limit and the lower limit, that variation is called the jitter. Performance tactics. So now coming to what are the ways in which we can improve the performance. First, let us look at what are the reasons why performance can be impacted. So can you state some important reasons why the performance may be affected? So load, bad algorithm, bad connectivity, incorrect sizing, hardware limitation, wrong choice of algorithm, coding issues, network bandwidth. Okay, good. Okay, so these are some of the good reasons you are given. Here are some, maybe you already mentioned that the algorithm use is not appropriate, database retrieval is low, volume of data to be processed is very high, number of concurrent users may be very high, database server gets too many read requests, and the response for frequently used transaction is slow. Okay. So before that, let me take one question here. I think Omkar is asking, what is significance of calculating jitter as long as it is meeting maximum response time? So it is one of the characteristics of response. So typically you want reliability in the way the response comes. So for example, when you order, when you are suppose you are a customer of a bank, and the bank sends you a statement, say on the 1st of every month, and it is probably at the most it may get delayed by 2 days, right? So so on the 1st of every month or 2nd of every month you get a statement. So your expectations are within 1 or 2 days you will get a statement. But if the statement comes 5 days afterwards, then even though it is not a very big delay or 3 days, you start wondering to why it has not come, right? So the idea is to ensure that we don't cross the limit. So what is the maximum allowed jitter is sometimes a requirement from the end users or from the stakeholders, right? Okay, so coming back to the performance tactics. So if the algorithm is not good, then we can look at a better algorithm. Database retrieval is slow. If the database is slow, what can we do? Okay, we can do the indexing, we can do the tuning of database, we can do caching. Excellent. The volume of data to be processed is very high. What can we do? What are the techniques we can use? Parallel processing, very good. So distribute the data on multiple servers and do the processing in a parallel manner. Chunk the data, load balancing. Okay, good. If the number of concurrent users is very high, increase the number of servers and do the load balancing. Okay. Horizontal scaling, multiple servers to process the request. Excellent. Database server gets too many read requests. If there are too many read requests to a database, we can do replication. Okay, good. We can do caching, parallel hits, distribute the request. Okay, excellent. The response of frequently used transactions is slow. Optimize the code. Okay. Again, caching, need to look for. So caching seems to be a common answer here. Optimize the bandwidth, indexing. Okay. So let's look at some possible solutions. Improve the algorithm. Database retrieval is slow, index. We should talk about all this. Volume of data is high, distribute data with low. Number of concurrent users, distribute. Okay, we think we have discussed all this. So here are some architectural solutions. So we did talk about load balancing as one of the mechanisms to address the performance. So you can have multiple servers, and as the requests come from different clients, the load balancing component will determine to which server the request should be sent. Now there could be many approaches. One approach is called the round robin. So as it gets requests from different servers, the first one is sent to the server 1, second is sent to server 2, third is sent to server 3, fourth is sent to server 1, fifth is sent to server 2. So basically it goes in a round robin fashion and keeps distributing the requests in a round robin way. There is another approach is based on the transaction load. So when it gets a request, before it gives it to any of these servers, it finds out or it determines which server is least loaded, and then it sort of distributes the request. This is because if you simply go by round robin, some requests may take less time and some requests may take more time for processing. So even though you go in round robin, the first server might not have finished its work. So it would have been, if we give the request to the first server again, it will become overloaded. So at any given time, we check which server is having minimum load and distribute the work to that particular server. Okay. Now here is a situation where there are multiple read requests at the same time. Okay. So here, if you have a simple system before where we have different clients and one single database, and if there are too many read requests, they'll get sort of choked because there's only one database. So what you can do is you can have multiple copies of the same database. Only one copy is used for writing, whereas if there is a read request, it can be distributed to other servers as well. So whenever it is written, that whatever you write is then synchronized to other servers as well. Do you know how YouTube is able to cater to the large amount of viewers across the globe? Distributed systems, distributed computing, They use edge locations. Okay, that's good. So essentially they use a technique called content delivery network. So instead of having one server, YouTube server for the whole world, where all the requests come in, they have multiple servers, and each server will have copies of the same videos, or at least all the popular videos. So if I am a requester from India, I will be I will be directed to the server which is closest to India, and my streaming will happen from that particular server. Similarly, if I am in Australia, it will be Australia, it's the US. So there are a lot of servers, and the most popular content is replicated, so that the load on the server is less, number one, and also it is closer to your location, so the amount of network requirement for transmitting that will also be less. So this is called the content delivery network. So again, the basic principle is replication of data, right? And do you know how Google returns the results so fast? Within less than 1 second, you are able to get in many cases you are able to get the response. So what they do is, they don't, when you say search for software architecture, it doesn't go and search the internet. It actually keeps a copy of the data of the internet and indexes it into their servers, and it searches in that index, and also it maintains this index information in different data centers across the globe. And in each data center there are hundreds of computers. So when you say search for data architecture, it searches in all the computers in the data center parallelly, and then each server will return the search results. They're put together, and then other processing is done, and result is sent back. And it also stores sometimes the entire index in the RAM instead of the disk, because actually disk is pretty slow. So these are some of the techniques that Google uses to improve the performance and give it to us in a split second, right? Now coming to the next quality attribute. So shall we take a 10-minute break? It is 8:49 now. Can we connect back at 9 o'clock? Yeah, thanks.